This training video is the first step in becoming a certified telescopic boom operator with Maryl Group Construction. After the completion of this video and passing a written test, you will receive a practical test by the Maryl Group Construction Project Superintendent or equivalent to evaluate your skill level on the gradle. If the project superintendent gives you a passing practical eval score based on your observed skill level while operating the gradle, the Maryl Group Safety Manager will then assign you an operator card. Refresher training, including an evaluation of effectiveness of this training, will be conducted to ensure that the operator has the knowledge and skills needed to operate the gradle. This will occur when the operator has been observed operating in an unsafe manner, post-accident or near miss, or changes in workplace conditions, or every 3 years as your operator card reaches its expiration. Causes of tip-overs. The most common cause of a tip-over is going around a corner too fast without a load. Turning with the forks above travel height, loaded or unloaded. Handling a load that is too heavy for the gradle does not cause as many tip-overs as one might think. Why? Because when engaging the load, the gradle gets light and we learn to keep such a load close to the ground. Common reasons why workers are struck by gradles occur when driving with the load obstructing your vision, turning and not watching the rear end swing of the gradle, or backing up and not paying attention. Think before you act. Accidents that cause injuries and death come suddenly, and everyone is left scratching their heads and wondering what went wrong. Usually, it is because they have been cutting safety corners for years and the odds finally caught up to them. After the accident, it becomes evident that they weren't being as safe as they thought they were. How safe are we being? Even beavers need to think before they act or suffer the consequences. How do gradles compare to automobiles? First off, a gradle is not for personal use. They typically weigh more than 5,000 pounds and they're rear wheel steering. Operator training and certification is required and operates on various surfaces. Automobiles, on the other hand, are for personal use. They typically weigh less than 5,000 pounds, front wheel steering. They also require training and operate mainly on paved roads. The operator and maintenance manuals are required to be on board at all times. All operators are required to understand these manuals prior to making any lifts. And also, all operators must conduct daily and shift inspections before any lift occurs. All the telescopic boom lifts on our site will include the key signal words with danger indicating an imminently dangerous situation that, if not avoided, will result in death or serious injury. Warning also indicates death or serious injury, and the caution indicates a potentially hazardous situation, if not avoided, may result in a minor or moderate injury. All the gradles on our sites will display these key signal words along with a message about the potential injury situation. Familiarize yourself where the different warnings are on the telescopic boom forklift that you are operating, and also familiarize yourself with the situations that can cause an accident and how to avoid them. Safety decals. All decals must be legible and kept intact as provided by the manufacturer. Illegible labels need to be replaced. Do not disregard the importance of these labels. Each of these components will be discussed in more detail later in this training. Also, telescopic handlers vary somewhat from manufacturer to manufacturer. Pre-operation visual inspection. Visual inspection should include checking the overall condition, the frame, tires, forks, overhead guard, engine compartment, electrical equipment, control labels and markings, and also the operator's compartment. This inspection must be done at the beginning of each day or shift to ensure that no hazards are present. A significant number of forklift accidents occur as a result of faulty equipment, which would have been identified if a pre-operation inspection would have been performed prior to use by the operator. Pre-operation inspection. Damaged overhead guards should be repaired, as damaged guards will not adequately provide the protection necessary from falling objects. Inspect suspension systems for loose bolts. Ensure operator cab is clean with no grease or mud to prevent slipping. Gauges and controls along with labels need to be clean and legible. Check for leaking fluids such as fuel, coolant, hydraulic fluids, etc. Check for structural welds and cracks. Check the engine compartment to ensure that it is safe and clean. Operational inspection. Ensure that the seatbelt is functioning properly. Test warning devices such as horn, lights, and other devices. Check all gauges to ensure that they are functioning properly. Test hydraulics by extending and retracting the boom. Verify steering by turning the wheel completely from left to right. Test parking brake and service brake. Test sway controls. And any control that functions erratically or slow to respond needs to be repaired prior to using the Gradall in any Maryl Group construction projects. After the completion of the inspection, report all defects to the Maryl Group construction supervisor. Never operate a Gradall or any equipment in need of repair, and only authorized and trained personnel will make the repairs. Load center of gravity is defined as the point in the load around which all weight is evenly distributed. Rated capacity. The manufacturer rates the capacity of the telescopic boom forklift for a specific weight located at the specific point on the forks. See the picture to the right. If the load center of gravity varies from the specific load center, then the capacity of the Gradall changes. Telescopic handler stability. The front wheels are the pivot point of balance in the fore and aft directions. The machine center of gravity, or CG, will be somewhere in the vicinity of the engine. The weight of the machine behind the front axle times the distance from the axle to the machine center of gravity produces the offsetting torque. The weight of the boom, forks, and the load ahead of the front axles times the distance from the front axle produces a tipping torque. The offsetting torque must always be greater than the tipping torque. The offsetting torque is basically fixed and remains constant. The tipping torque can be increased by increasing the load weight or extending the boom out, or both. And when the load is lifted, a combined center of gravity is produced and will always be on a straight line between the load's CG and the machine's CG. Changing stability. The combined center of gravity will move forward as the load is moved forward by extending the boom. If the combined CG, or center of gravity, moves past the front wheels, the machine will tip forward. As the load is raised, the combined center of gravity will move upward also. Note that the combined CG will move backwards slightly when the boom is raised, but not extended, as depicted in the picture to the right. A combined center of gravity has its greatest impact on stability when the machine is moving. Changing stability. Extending the boom with a heavy load will result in the machine tipping forward if the tipping torque becomes greater than the offsetting torque. Operators need to be cautioned that a load that is stable close to the machine will become less stable as the boom is extended. And the weight of the load along with the load chart needs to be taken into consideration before extending any loads. Lifting capacity chart. Make sure that you review each part of this chart. When the letter becomes visible on the boom as it is extended, the lift capacity then is reduced to the next lower capacity, regardless of how little the boom is extended beyond the visibility of the letter. The lifting capacity decreases as the extended boom is lowered, and the reason is that the tipping torque increases due to the horizontal distance between the load's center of gravity and the front axles increasing. And also remember, the lifting capacity shown is for the machine being perfectly level on a solid surface and with no wind. The lift capacity chart must be legible and visible to the operator. The chart shows the machine's lifting capacity at different boom lengths and boom angles. Review the diagram and make sure that you understand each part of the chart. If the machine has stabilizers, note how the lift capacity increases when the stabilizers are properly deployed. See the picture to the left. The operator needs to make sure that he or she is referring to the correct chart when determining the load limits. Adding attachments. The capacity of the gradall is affected any time an attachment is added to the machine. The attachment will add weight to the machine, causing it to be partially loaded. The additional weight may extend the load center. And remember, adding an attachment to the machine requires manufacturer's approval and a new capacity plate installed when using the attachment. Dynamic and static conditions. The telescopic handler's balance is affected by both static and dynamic conditions. Static conditions are those which affect the telescopic handler when it is not moving. Dynamic conditions are created when the telescopic handler is moving. Static conditions include load size, load shape, position of the load on forks, lift height, amount of tilt, and tire pressure. Dynamic conditions include acceleration, speed, braking, ramps and slopes, raising loads, and lowering loads. The law of motion states that an object at rest wants to remain at rest, and an object in motion wants to remain in motion unless acted on upon an external force. These two laws impact the stability of the machine when moving a load. When a gradall is transporting a load stops, the load wants to continue moving, and the additional force created by this movement will want to tip the machine forward. The pivot point for this tipping motion is the front wheels, and the distance from the ground to the load center is the effective lever arm. The forward motion of the load times the effective lever arm will produce a dynamic tipping torque. This dynamic tipping torque is added to the static tipping torque, which the offsetting torque must oppose or the machine will tip over. The amount of forward force is dependent upon how fast the machine is stopped. Braking fast will create greater tipping torque, while slowly coming to a stop will produce a small tipping torque. The higher the load is elevated, the greater the effective lever arm, and therefore the greater the dynamic tipping torque will be. See the picture to the right. The higher the load is carried when transporting it, the greater the risk for a tip over. Moving the machine with the load low has minimal effect on stability. The dynamic tipping torque for this situation is small, and thus the machine is less likely to tip over when braked. When making a turn, the higher the load, the greater the effects on the centrifugal force. The machine's lateral stability can be affected by dynamic forces created when taking a turn. Making the turn with the load raised high allows the centrifugal force to create a greater dynamic tipping torque than if the load is low. The problem becomes compounded when the machine is making an uphill turn. On level ground, the combined center of gravity will be on the machine's center line. Lateral stability is the stability of machine from side to side. When the load is carried low to the level ground, the combined CG will be on the center line. This is the most stable positions for traveling with a load. Lifting suspended loads. When using a crane arm, a lift capacity chart for the telescopic handler needs to be provided by the manufacturer. When placing a crane arm on the telescopic handler for lifting suspended loads, the manufacturer needs to be consulted to determine the new lifting capacities. Care must be taken to prevent the load from striking the boom. This could result in the boom collapsing. Crane arms must be engineered with an established capacity identified. Soil bearing strength and stability. Stability also depends on the strength of the soil to support the front tires or stabilizers. As the load extends forward, the combined center of gravity moves forward, transferring more weight to the front wheel. The stability of the machine can change dramatically if the pressure on the soil by the tires is greater than the soil strength. Exceeding the soil strength will result in the tires sinking, which, in turn, can cause the machine to tip forward or over the side. This chart shows the soil strength of various types of soils. The purpose of this chart is to show how soil strength can change. Typically, the soil strength around construction sites is poor because it has been disturbed. Safe operating guidelines. Only trained and authorized operators shall be permitted to operate a telescopic handler. Before beginning to operate the telescopic handler, the operator must always fasten his or her seatbelt, place directional controls in neutral, disengage the clutch on the manual transmission, or apply the brake on the power shift or automatic, and then start the engine. Always keep your hands and feet inside the operator cab and never put any part of the body into the mast structure or within reach of moving parts. Always take caution of overhead hazards such as bridges and power lines. Exercise care at cross aisles, doorways, and other locations where pedestrians may step into the path of travel. Do not allow anyone to stand or pass under the elevated portion of the boom, whether it has a load or not. Maintain a safe distance from the edge of ramps, platforms, and other similar working surfaces. Do not block access to fire aisles, stairways, and fire equipment. And never permit passengers to ride on the machine. Attended versus unattended. A telescopic handler is attended when the operator is less than 25 feet from the truck and the truck always remains in his or her view. A telescopic handler is unattended when the operator is 25 feet or more from the truck or is out of the view of the truck. Attended parking requires the transmission to be in neutral, parking brake set, and forks on the ground. Unattended parking requires the same as attended, with the engine shut off and the wheels blocked off if it's on an incline. Traveling. Keep a clear view of the path of travel. If the load obstructs your view, travel in reverse or use a spotter. Travel at speeds that will permit it to be stopped in a safe manner. Travel with the forks or the load tilted back if possible. And do not elevate the load except when stacking. Make starts, stops, turns, or directional reverses in a smooth manner so as not to shift the load or overturn the truck. Slow down your speeds when on wet or slippery surfaces. And never indulge in horseplay or stunt driving. Try to avoid running over loose objects on the ground. Lateral turnover is greater when the forks are empty. Negotiating turns. Know which steering mode you are in. Before changing modes, align the back wheels. Reduce speeds to a safe level. Turn steering wheel in a smooth, sweeping motion. Never turn while the load is elevated except very low speeds. Turn steering wheel at a moderate, even rate. Ascending or descending grades. On grades 5% or more, load should be upgrade. Empty forks should be downgrade. On all grades, the load should be tilted back and raised only enough to clear the road surface. Avoid turning if possible. Normally travel straight up and down. Loading. Use stabilizer controls only in compliance with the manufacturer's instructions. If equipped with lateral leveling, always level the frame before raising the boom. Lateral leveling should never be used to position an elevated load. Handle only stable and safely arranged loads. When using attachments, make sure they are properly used and secured. Completely engage load with forks at least 2/3 under the load. Use extreme care when tilting the load forward. And never use a gradle to elevate personnel on Maryl Group construction projects. Power line contact. The minimum clearance requirements need to be observed at all times. A 10-foot clearance is required for 50 kV and below. 50 to 200 kV is 15 feet. And 200 to 350 kV is a 20-foot clearance. It may be necessary to have an assigned spotter to watch the boom to ensure that it does not enter into the danger zone. Electrocution is the #1 cause of death involving cranes. If power line contact occurs, the operator should remain within the machine if at all possible until the power company indicates that it is safe to leave the machine. This is because the telescopic handler components could be at different voltage potentials, and touching parts of the machine could result in being electrocuted. If you come up on a situation and the operator is unconscious, do not attempt to touch the gradle or make rescue until the power company has deemed it safe to do so. If a fire occurs and the operator must leave the cab, he or she should shuffle their feet to clear the area of the power line contact. Refueling. Only refuel when the engine is cool in a designated area. Fire extinguisher available and parked in unattended mode. Do not top off the tank, and remember no smoking, flames, or sparks, and clean up any spills. Calculating load weights. Here are some examples of common materials and their unit weight. To find the weight of any item, you need to know its volume and unit weight. Volume times unit weight equals load weight. Unit weight is the density of the material. Unit weight is normally measured by pounds per cubic foot. Calculating volume. Multiplying the length by the width by the height equals your volume of a cube. Measuring the volume of a cylinder is a little more difficult, but not rocket science. Having a scientific calculator and knowing how to use it is a good idea. Weight tables. Weight tables are an excellent way to calculate load weight. If you are handling certain materials often, then having a chart that gives you the weight per cubic foot, cubic yard, square foot, linear foot, or per gallon would be good to have. Metal plates. Steel plates weigh approximately 40 pounds per square foot at 1 inch thick. Half an inch thick would then be about 20 pounds per square foot. A steel plate measuring 8 foot by 10 foot by half inch would then weigh about 3,200 pounds. Post-video practical testing. This portion of your training will be conducted by the project superintendent or project competent person to evaluate your skill level while operating on an obstacle course created at this site. Practical test requirements will include operator walk-around visual check, use of seatbelt, the proper startup, use of safe and controlled speeds, successful negotiation of cones, mirror use, head checks, fork positioning while lifting pallet, operator able to find center of gravity for the load, stability of the load, successful lift of a pallet, traveling with the pallet, successful pallet drop, proper shutdown, setting of the brake, fork and boom lowering, setting truck to neutral, and engine shutdown. This will be followed by the evaluated questions, in which the operator must also be able to answer, including where use and inspection checklist documents are to be kept, how frequently inspections are to be conducted and documented, and where the manufacturer's manual is to be kept, and more.